Good morning, students. Myself, Vijay Shankar from EC Department, Chipol Engineering College. So today we are going to discuss about the inverse J transform examples, the last class for the last chapter in our syllabus. So we already discussed about the inverse J transformation by using the four methods. So one method is power series method or the long division method, and second method is partial fraction expansion method, and third method is a residue or a counter integration method, and the last one is by using the convolution property, how to find out the given x of z function in the time domain function x of n. The last topic here, linear time invariant system. Linear time invariant system. So the x of n, the discrete time signal is given to the system. That system is a linear time invariant system, h of n. To get the response is a y of n. The response is nothing but here the output. The input is a discrete time signal. It passes to the linear time invariant system. The linear and also the time invariant. For the linear time, discrete time system will be represented by the difference equation. Remember, my dear students, by the difference equation. What is the difference equation? Sum of k equal to 0 to n is a finite duration here. A suffix k, y of n minus k. And that is equal to sum of k equal to 0 to m, here the capital M, my dear students. B suffix k, x of n minus k. So difference equation. X is nothing but the input value and y is the output function. So here the input function is x. Here we represented the x is x of n minus k. That k value having the 0 you can substitute, we'll get the x of n. And 1 we can substitute x of n minus 1. And so on. Means it depends upon the present and the past inputs. This is a past input. Okay. And similarly, here in the left hand side, you can observe, you can substitute k is equal to 0. It becomes of y of n and y of n minus 1. This is y of n is a present output. Y of n minus 1 is a past output. See, in the input and output, it is not at all depends upon the future inputs and the future outputs. Only it is depends upon the present and the past inputs, present output and the past outputs. Okay. And now we know the Z transformation, x of n, the Z transform is x of z. And here the Z transform of the shifting function, time shift function. The time shift function we have x of n minus k is x of z. Whatever the samples we are shifted towards the right side can take as a negative powers of z, z power minus k. If x of n plus k is there, you can get it is a z power minus k is becomes of plus k. But it matters, friends. Now use the sum of k equal to 0 to n a suffix k z power minus k y of z, and apply the Z transformation on both sides of this equation. The sum of k equal to 0 to n a of k. And what is the shifting operation we are applying here? Z power minus k y of z and z power minus k x of z in the right hand side. So y of z by x of z is a transfer function of the system function. Transfer function or system function we are calling it as. That is equal to sum of k equal to 0 to m, b suffix k z power minus k up to this. And here also divided by sum of k equal to 0 to n a suffix k z power minus k. When I am taking the y of z by the x of z cross multiplying, You can call it as a system transfer function or system function h of z is equal to sum of k equal to 0 to m b suffix k z power minus k whole divided by sum of k equal to 0 to n a suffix k z power minus k. Got it, my dear student? System transfer function, or it is a system function. Transfer function means output by the input. Got it, my dear students? Then indicating that the impulse response or the impulse response of the transfer function. Impulse response means the y of n is y, that is delta of n, or the h of n we are calling it as the impulse response. Impulse signal is a delta of n. Impulse response is a h of n. After applying the z transformation of this impulse response, we're getting the h of z, nothing but the system transfer function. Okay. Delta of n is given to the system, linear time invariant system. The response is impulse response, nothing but the h of n. For the impulse signal passes through the system, we'll get the impulse response. And this impulse response, whatever we got, apply the z transformation, we'll get the h of z, calling it as y of z by the h of z is a system transfer function or system function. Got it, my dear students? So given function, the y of n minus 3 y of n minus n is equal to x of n. X of n. It's a linear time invariant system of the differential function. Apply the z transformation on both sides for the given function. Y of n is nothing but y of z here. Minus 3 y of n minus 1 z power minus 1 y of z. That is equal to x of n. The transformation is x of z. Take the y of z is a common here. Y of z into 1 minus 3 z inverse x of z. So y of z by x of z is equal to 1 by 1 minus 3 z inverse. Or you can also written as a z by z minus 3. Z minus 3. According to that, it is a z by z minus a. The a power n mu of n. What is the z transformation here? A power n mu of n z transformation is 1. In the positive powers of z is z by z minus a. In the negative powers of z is a 1 by 1 minus a z inverse. Okay. Now here the positive powers of z, instead of a, 3 value is there. So what is the h of n is equal to 3 power n mu of n. Impulse response. Calculate the system impulse response. System impulse response, or it is a transfer function. The given function, it is y of n minus 3 y of n minus 1 is equal to x of n. H of n is equal to, we got the impulse response. Similarly, take the second example. You can see here y of n plus 0.5 y of n minus 1 plus 2 into y of n minus 2 plus 3 into y of n minus 3 plus 0.5 y of n minus 1 is equal to 3 into x of n plus 5 into x of n minus 2. Apply the z transform on both sides. What is the y of n? The transformation is y of z plus y of n minus 1. The transformation is z power minus 1 into y of z, already taken as a common. And for the third term, y of n minus 2, z transformation is z power minus 2 y of z. And fourth term, y of n minus 3, z transformation is z power minus 3 y of z. And the last term here, it is a fifth term, y of n minus 4, the transformation is z power minus 4 y of z is equal to 2 terms in the input function, x of n, the transformation is x of z, x of n minus 2, the transformation is z power minus 2 x of z. On both sides, we can take here the y of z is a common and the x of z is a common. Write as output by the input y of z by the x of z. 3 plus 5 into z power minus 2 and denominator 1 plus 0.5 z power minus 1 plus 2 into z power minus 2 and 3 into z power minus 3 and 0.8 into z power minus 4. Nothing but it is a x of z, calling it as a system function or the system transfer function, output by the input. Got it, my dear students? Now, you can find out the factors here. You can find out the factors in the denominator, and by using the partial fraction method or residue method, whatever the method you can use to find the impulse response of the h of z. Impulse response of the h of z. Got it, my dear students? So today you'll get the four factors here, the 4 poles, or convert, first of all, convert into the positive powers of the z. Then after you can find out the poles to get the impulse response over h of n. Impulse response h of n. Got it, my dear students? And another example also we have here, y of n is equal to y of n minus 1 plus, or the y of n is equal to y of n minus y of n minus 1 plus y of n minus 2 plus x of n minus 1. It is equal to only, my dear students. This is equal to. Apply the z transformation on both sides. Y of z is equal to z inverse y of z, z power minus 2 y of z plus z inverse x of z. Take the two terms in the left hand side, 1 minus z inverse minus z power minus 2, take the y of z as a common. Write the y of z by the x of z and convert into the negative powers to the positive powers, the z by z minus 1 by 2 whole square minus 3 by 4. Okay, z by z minus, it is in the form of cos, not the cos, okay, cos only. Z by z minus a whole square minus b here. Using that, any one of the function we have, we can multiply that a power n v of n. It is now, it is a power n into cos function also will get. Whenever you can find out the h of z in the impulse response. But here we are finding only the system function only. For the second example and the third example, we are finding out only the system function. If we want the impulse response also, by using the partial fraction method or any one of the method, use that and find out the impulse response. And here it is a direct function only. Z by z square minus z minus 1, it is in the form of z by z minus a whole square minus b. It's a constant here. To get it here, the constant h of z by z is equal to x of z by z, like that. Okay. And the next example, fourth example also, the y of n is equal to, or the y of n is equal to y of n minus, it is not the function, there is no anything here. Y of n minus 2 minus 3 into y of n minus 1 plus 2 into y of n is equal to x of n minus 1. Apply the z transformation for this. Y of n minus 2. Y of n minus 2 is y of z into z power minus 2 minus 3 into y of n minus with z transformation is z power minus 1 y of z, and 2 into y of z, that is equal to x of n minus 1 z transformation is z power minus 1 x of z. So take the y of z as a common in the three terms. Y of z by z, x of z is equal to z inverse, and the 2 minus 3z inverse plus z power minus 2. Convert into the positive powers, z by 2z square minus 3z plus 1. Write the factors in the denominator. 2z minus 1 and z minus 1. Using the partial fraction expansion method, you can get the a is minus 2 and b is 1. And impulse response for the h of z, h of n is equal to, it is in the form of z by z minus a. What is the a here? 1 by 2. So minus 1 by 2 whole power n mu of n. And z by z minus 1, 1 power n mu of n. So without giving any ROC, you can write it is always in the right hand side only, my dear students. Here, why we are writing it's a mu of n without having any ROC is a greater than or it is a less than or in between. If they mention, you can write down whether it is in the right hand side or the left hand side or in between. If they not mention, directly they are asking to find the impulse response without asking any ROC or given in the ROC. Default you can use in the right hand side only. Minus 1 by 2 whole power n mu of n, and the z by z minus 1 is 1 power n mu of n. Got it, my dear students? Next, calculate the x of n for x of z is equal to z by 2z square minus 3z plus 1, and magnitude of z is less than 1 by 2 by power series method, partial fraction method, residue method, and the convolution method. So they're asking that it is a given x of z is given using all the types of inverse transformation. You can find the x of n value for the given x of z. So what is the x of z is z by 2z square minus 3z plus 1. Z is less than 1 by 2. So less than means represent the numerator and the denominator or in the descending powers. The descending powers. So take here z power minus 1, z power minus 2 minus 3 z inverse plus 2. So when we are converting it to the positive powers, when we are going for the partial fraction method, but the power series method, you have to keep that in the negative powers of z only. So z inverse you can divide with the z power minus 2 minus 3 z inverse plus 2. In the descending order, the z power minus 2 and z power minus 1 is there. You can take here the z and goes on to find the value z plus 3z square plus 7 z cube and 21 z power 4 and 63 z power 5 will get. Okay, take that coefficient value z plus 3z square plus 7z cube, 21 z power 4 and 63 z power 5 and so on. Z power minus n multiplication is for x of n, and z power n is multiplication is for the x of minus n. Here it is a positive power, so we will get so x of minus 1. What is the coefficient here? This is z power 1 means definitely it is multiplied with the x of minus coefficients. X of minus coefficients for the positive powers of z. So x of minus 1 is a 1, and z power 2. What is the coefficient here? X of minus 2. So x of minus 2 is a 3. X of minus 3 is a 7. X of minus 4 is 21. X of minus 5 is a 63. And x of minus 6 is a 189. And so on. So we got the values is x of minus 1, minus 2, minus 3, minus 4. All you can write from mine. So on. 189, 63, 21, 7, 3, 1, and the 0. Because there is no any value at n is equal to 0. It's not at n is equal to 1. Okay. The x of n having the sequences, the value is 189, so on the 189, 63, 21, 7, 3, 1. Because x of minus 1 is a 3, minus 2 is a 3, x of minus 1 is a 1, minus 2 is 3, minus 3 is 7, minus 4 is 21, minus 5 is 63, and minus 6 is a 189. So using the power series, first of all, you can see that if it is a less than means the left hand side only. All the values in the left hand side. Because of that, you can write as a descending order. If suppose it is a greater than means you can reverse. Check that it is a 2 plus 2 minus 3z inverse and the z power minus 2 is divided with the z inverse. It's a reverse order. The ascending order we can take and we'll get in the negative powers of z and take the coefficients is from the 0 to infinity. And coming to the second one, partial fraction expansion method, x of z is equal to z by 2z square minus 3z plus 1. So definitely by using the partial fraction expansion method, you have to convert the given function to the positive powers. Already the given function is a positive power. And find the roots in the denominator. What is the roots by using this formula minus b plus r minus square root of b square minus 4ac by 2a. We got the 1 and the 1 by 2. So z minus 1 and 2z minus 1. So 1 by 2 means that is a z minus 1 by 2 only. Okay, my dear students. Or otherwise you can see that z minus 1 and 2z minus 1. The function you can multiply these two. 2z square minus 2z and minus z is a minus 3z and minus into minus is a plus 1. This satisfies the condition. So x of z by z is equal to z1 by z minus 1, 2z minus 1. Okay, 2z minus 1. Find the a and the b values by using the partial fraction expansion and cross multiply the z by z minus 1 minus 2z by 2z minus 1. And in this, we can take the common of the 2 here, 2 to get cancelled, z minus 1 by 2. Z minus 1 by 2. Now it is in the form of z by z minus 1. Another one is z by z minus 1 by 2. Because they are asking it is a left-hand side, ROC. Now you can write the z by z minus 1, the first function. Z by z minus 1 in the left hand side, that is minus 1 power n mu of minus n minus 1, and here already in the term having the minus is there. For applying the inverse Z transformation, z by z minus 8 is a minus of plus 1 by 2 whole power n mu of minus n minus 1. Since it is a ROC is less than 1 by 2. Don't see that the value here. Less than means definitely the two terms you can write in the left hand side. Greater than means all the terms you can write in the right hand side. When we can see the value here, whenever if it is in the in between there is any value means 1 we can see which is greater than or less than, 1 by 2 if it is a greater than or less than, you can write that according to that values. Okay. So we completed the power series method and the partial fraction method for the given x of z, and residue theorem and the convolution. Third method. So this by using the residue theorem. We know the formula, the residue theorem formula. If you're having any factors is there, that is zi is equal to 1 and 1 by 2, only the one time it repeats, one time only. We have 1 by k minus 1. The formula is 1 by k minus 1 factorial dou power k minus 1 by dou z of dou z k power minus 1 and z minus zi whole power k x of z and z power n minus 1 at z is equal to zi. Got it, my dear students? This is a residue method you have to find out for any given function. So first off, I am taking the zi is equal to 1. So zi is equal to 1. What is the k there? Zi is equal to 1. What is the k? It's only the one time. Okay, 1 by 1 minus 1 factorial. 0 factorial is a 1. Dou power is also only the one time we have to get the minus 1 So if I am not taking directly, it is a k is equal to 1 time. In this substituting value, it becomes of a k minus 1 is z minus 1 x of z and z power minus n minus 1 z1, that is equal to 1. And similarly here also the one time only, you can apply here the dou by dou z of only the one time, dou by dou z of z minus zi, that is a z minus 1 whole power k is equal to 1. You can take the k is equal to 1 x of z, that is a z by z minus 1 into z minus 1 by 2 and z power n minus 1 to 1, because the value is 1 only here. Okay. Only if it is a one time, you can take it is a derivative is a one time only. Got it, my dear students? If k is equal to 1, no need of taking that is a k minus 1 is a 0. Don't think it is a dou power 0 and dou power z is. And you can apply that is a dou power z and the dou power 0. So value is 1 only. And z minus 1 and the z power z minus 1 will get cancelled. And z by z minus 1 by 2 and z power n into z power minus 1 at z is equal to 1. Okay. See what is the z power plus 1 and z power minus 1, it becomes of the 1 value. Z power n by the z minus 1 at z is equal to 1. Don't apply here the z derivative because it's a dou power 0 by dou power z power 0. No need to apply the derivative here. Directly can substitute z is equal to 1 in this function. 1 power n whole divided by z minus 1 by 2. Z minus 1 by 2, the 1 minus 1 by 2. The value is a 1. So we got the 1 power n only for the first function. 1 power n. Second function is C. The same thing, dou power 0 by dou power z, because it is a k value is a 1, but z is equal, zi is equal to 1 by 2. Zi is equal to 1 by 2. So second function, it is a dou power 0 by dou z power 0 and the 1 by 0 factorial is a value is a 1. Now it is a z minus 1 by 2 whole power 1, z by z minus 1 and z minus 1 by 2, z power n minus 1 at z is equal to 1 by 2. So z power 1 by 2, z power 1 by 2 get cancelled. No need to apply the derivative here because it is a dou power 0 by dou z power 0 and z by z minus 1 into z power n minus z. So here also the power 1 and minus 1 is get cancelled. Z power n by z minus 1 at z is equal to 1 by 2. I can substitute the 1 by 2 here plus 1 by 2 whole power n and 1 by 2 minus 1. It becomes of minus 1. So these are the two factors we got. But the given it is in the left hand side. So left hand side means the value it becomes of minus 1 whole power n mu of minus n minus 1. Already we have here the minus is there. Now minus and minus is a plus becomes 1 by 2 whole power n mu of minus n minus 1. Okay, this is the final answer by using the residue method. You see here x of n is equal to minus mu of minus n minus 1. There is no any value of 1 power anything is a value is 1 only. And second term plus 1 by 2 whole power n mu of minus n minus 1. Got it, my dear students? So using this formula 1 by k minus 1 factorial dou power k minus 1 dou z k minus 1 z minus zi whole power k x of z power n minus 1, where the z is equal to zi. Using this formula you have to find out the by using the residue method for the given function x of z in terms of x of n. Okay. And the next one, the last method, fourth method, the convolution method. Given function is z by 2z square minus 3z plus 1. So z by z minus 1, 2z minus 1. Take the two functions as of x of z is equal to the first one, z by z minus 1 is x1 of z, and 1 by 2z minus 1, otherwise 1 by 2 into 1 by z minus 1 by 2 as x2 of z. Okay. Apply the inverse z transformation because z is less than 1 by 2. You can write as minus of 1 whole power n mu of minus n minus 1. x2 of n is minus of 1 by 2 whole power n minus 1. Why it is n minus 1? I already told a power n mu of n. Z transformation is z by z minus e. Z by z minus e in the positive power subset. Similarly, for a power n minus 1 mu of n minus 1, z transformation is 1 by z minus e. Remember this. 1 minus 1 by z minus e. A power n minus 1 mu of n minus 1. Shifting one sample towards the right side. Okay. So it is in the form of 1 by z minus e. So 1 by 2 already there. It is a constant coefficient. Simply you can say 1 by 2. So for the by using this formula, x2 of n is equal to already the 1 by 2 is there. Because of it is a less than term, I'm taking the minus 1 by 2 whole power n minus 1, not the n minus 1 mu of n minus 1 minus 1 minus of, okay, minus of n minus 1 minus 1. So simplify this minus 1 by 2 here, the 1 by 2 whole power n minus 1. Already the one term is a 1 by 2 here. So minus of 1 by 2 whole power 1 and 1 by 2 whole power 1, it becomes of 1 by 2 whole power n only. And mu of minus of n minus 1 means it becomes of minus n plus 1 and minus 1. So that is equal to minus 1 by 2 whole power n mu of minus n only. 1 and get cancelled here. Got it, my dear students? Here they wrote only for the z 1 by z minus a. That is, it's not taking that, it is a 1 by 2 here. For that case, we got a 1 by 2 whole power n minus 1. Okay. I simplified that is a 1 by 2. The total term, the minus of 1 by 2 whole power n minus 1. Here the plus 1 is there and minus 1 get cancelled. So 1 by 2 is already there here. That is equal to and 1 by 2. Got it, my dear students? Okay, using only the 1 by 2 whole power n minus 1 mu of minus n. Then apply the convolution x1 of n with the convolute of x2 of n. The formula is the sum of k equal to 0 to n. K equal to 0 to n, x1 of k and the x2 of n minus k. So the first function you can observe here, I substitute the k, n value as a k value, minus 1 power k mu of minus k minus 1. And the second term you can observe here, x2 of n minus k, wherever the n is there, you can substitute my n minus k, minus of 1 by 2 whole power, n is now n minus k minus 1. And here, mu of minus of n minus k, because n is n minus k. Mu of minus of n minus k. Got it? So sum of k equal to 0 to n, k equal to 0 to n, mu of 1 power anything, the value is a 1 only, my dear students. And here the minus is there, and here is a minus. Minus into minus becomes a plus. Mu of minus k minus 1, 1 by 2 whole power n minus k minus 1. And this becomes of mu of minus n plus k. Mu of minus n plus k value. Got it? So I am taking the mu of minus k minus 1 is equal to 1 when minus k minus 1 is greater than or equal to 0. Why? Now if you can take the mu of k is equal to 1, k equal to 1, definitely that we can say the k is greater than or equal to 0. Got it, my dear students? Similarly, the mu of function minus n plus k is equal to 1 when minus n plus k is greater than or equal to 0. What it having here? The k minus k is greater than or equal to minus 1 and k is greater than or equal to 1. K is greater than or equal to 1. And in this function, minus n plus k is greater than or equal to 0 means minus n is greater than or equal to minus k and k is less than or equal to n. Means if k is greater than or equal to 1 and the k is less than or equal to n means definitely that is in the range of 1 to n only. 1 to n. And otherwise, if suppose if we can take that value is 1 to n, now 1 power 2 whole power n minus k minus 1, n minus 1, the value is same function here because it is not related to the k, and sum of here they take it is n to infinite. Why it is n to infinite? They took that value is n to infinite. Actually, it is a 0 to n, 0 to n. Since it is in the value, it becomes of negative values. Negative values for all the values of the negative. It becomes of n to infinite. From n value, the k is less than or equal to n, the k is greater than or equal to 1. So actually, it becomes of 1 to n. I take that it is for the right hand side, 1 to n. The right hand side is a 1 to n. See here. I'll clearly explain that the convolution method is minus infinite to infinite here, minus infinite to infinite. Not is a 0 to infinite, 0 to n, my students. Keep it that is a minus infinite to infinite. And this is also minus infinite to infinite. Minus infinite to infinite. Then this minus infinite to infinite, now it becomes of by taking the k values as n to 1. N to 1. Not the 1 to n. The k is greater than or equal to 1 and the k is less than or equal to n means the sum of k equal to 1 to n values. In the range of 1 to n only. 1 by 2 whole power n minus k minus 1. Since these values are the k values only, so you can take the 1 by 2 whole power n minus 1 is a constant and sum of k equal to 1 to n 1 by 2 whole power minus k. Now it is in the form of 1 to n. The n1 is equal to, we know the formula is the sum of n is equal to n1 to n2. A power n is equal to, we have the formula is there, a power n1 minus a power n2 plus 1 by 1 minus a. Got it, my dear students? Now the sum of n is equal to 1 to n 1 by 2 whole power k. What is the a here? 1 by 2. What is the n1? 1 minus what is the a 1 by 2? What is the n2 n plus 1 whole divided by 1 minus 1 by 2. Simplify this now. Here the 1 by 2 minus 1 by 2 whole power n and n plus 1 whole divided by 1 by 2, because it is a 1 minus 1 by 2 is a 1 by 2. Already we have 1 by 2 whole power n minus 1. Already we have whole power n by 2 minus 1. But my students, 1 by 2 whole power n minus 1 is multiplied with 1 by 2 minus 1 by 2 whole power n plus 1 whole divided by 1 by 2. And already I told here there is a 1 by 2 is there. Since the 1 by 2, we wrote the 1 by z minus a value only 1 by 2 whole power n minus 1 mu of minus of n minus 1 minus 1. So 1 by 2 is multiplied. Here the 1 by 2 and 1 by 2 get cancelled. What my students? Still you can further simplify that 1 by 2 whole power n and 1 by 2 whole power minus 1. And in these two functions also, we can take the common as 1 by 2. 1 minus 1 by 2 whole power n. And 1 by 2 is get cancelled. See, in these two functions, 1 by 2, I take the common 1 minus, and here the n plus 1 is there. Already we got the 1 by 2. So 1 by 2 whole power minus 1 and the 1 by 2 is a value is 1 by 2 whole power 0. The value is a 1 ohm. Now 1 by 2 whole power again and multiply with 1 minus 1 by 2 whole power again. Got it, my dear students? Now even you can multiply this 1 by 2 whole power n minus and 1 by 2 whole power n and 1 by 2 whole power n. Which are same, you can add the powers. So 1 by 2 whole power n plus n, that is a 2n. This is a value of the function. Got it, my dear students? So after you can expand this by using the convolution method. For the given x of z, z by z, 2z square minus 3z plus 1, the final x of n is equal to 1 by 2 whole power n minus 1 by 2 whole power 2n. Got it, my dear students? Or you can simply use this sum of, it is not the sum of n is equal to infinite, my dear students. Is the value is changes depends upon the mu of minus k minus 1 and the mu of minus n plus k. Got it? So with this, we complete this transformation unit also. For third year triple students, 6th unit is completed, and for the second year ECE students, second year ECE students, 5th unit second part Z transformation. Okay, so with this class, totally all the syllabus what we have is completed as per the saying 2K. If you have any doubts, please raise, my dear students. I will clear your all the doubts in first unit to the last unit. So with these online classes of all the units, what we have as per the saying to you, 5 units of second year students, and the 6 units for the third year students as per the R16 syllabus is completed. Okay. Any doubts, my dear students? Okay, thank you and all the best.